22 tons of railcar, balanced upright on a single rail. With nothing either side of it and nothing holding it up, one steel wheel on one line of steel. That is the contact patch. Into the curve it leans, the way a motorcycle does. Nobody is steering it. No driver. No hands on the controls. Gillingham, Kent, 1909. This is the real machine. By 1910, 50 paying passengers on a London track. Look at the ground itself. A conventional railway needs two rails, the sleepers under them, and the earthworks under those. Louis Brennan, who had made a fortune inventing the world's first guided torpedo. The War Office listened. His pitch. Half the rail, half the sleepers, half the ground. Watch the flanges. A carriage bolted to two rails throws its passengers outward on every bend. Now, the same corner. His way. Free to roll, the car leans until the force runs straight down through the floor. Every monorail you have seen needs a beam. Brennan's ran on plain rail on the ground, which leaves one question about the machine. A wheel spinning inside a gimbal. Push against its axis and it will not move where you pushed. It turns 90 degrees from your hand. Push again and it does the same. Closer in. That turning is precession, and it is the whole of this machine. Everything Brennan ever built exists to aim it, and then to hurry it along faster. Torque applied one way, motion coming out 90 degrees round from it. Not a quirk. The direct arithmetic of adding a twist to a body that already carries angular momentum. Every time. Now drive it backwards. A motor forces the wheel around its vertical axis, and it shoves back hard enough to hold a loaded vehicle upright. That shove is the railway. Disturbance, precession, restoring torque, and level again. Then round that loop again for as long as the wheel spins. It never finishes. Turning that into a railway took Brennan 6 years. It began here in his own garden at Gillingham. A working model running on lengths of ordinary gas piping, laid straight across the lawn on timber blocks. Inside the shell, one flywheel and an electric motor, enough to keep a toy upright on a single line pivot, and it comes straight back upright, again and again. On the straight, the thing was faultless. Then it reaches a corner. Watch the track turn underneath the model, and watch the gyroscope hold its heading out in space, flatly refusing to turn with it. And the model drove itself clean off the piping and into the grass. From inside the vehicle, a track that turns is indistinguishable from a disturbance that needs correcting. So he used two of them, spinning opposite ways, geared so neither can move without the other, blind to steering. Sensitive to roll. Full size is 40 feet of vehicle and 22 tons of weight, set against a garden model a man could carry under one arm. What worked on the lawns must work up at scale. Two rotors, 3.5 feet across, 3/4 of a ton apiece, turning 3,000 times a minute inside sealed vacuum casings. And they never stop. Here is where the arithmetic turns against him. Tipping torque climbs with the mass of the car, and climbs again with how far that weight shifts outboard. Both of those grow with size. Natural precession climbs with neither of them. It arrives at the pace the wheel sets, and no faster, however hard, the car is falling. At 22 tons, the fall simply outruns the correction, and the machine loses that race every time. So, he stopped waiting for the gyroscopes to precess by themselves and started forcing them to do it on his schedule, not theirs. The righting force depends on how fast you precess it. Drive the wheel round harder, and it pushes back against you that much harder. The first attempt was purely mechanical. The axles stood proud of their casings. between two guide plates bolted to the frame. Tip the car, and an axle grips a plate and rolls along it, forcing the wheel round. It worked badly. Vibration made the axle bounce clear of the plate, so the correction came through in stutters. So the plates came off. In the final design, the gyroscopes are bolted to the chassis and roll with the car, turning with it. Their precession is no longer the correction. It has become the signal instead. Follow the linkage through. Axle drives rod, rod works lever, and the lever opens a valve. Nothing electrical anywhere in it. Compressed air floods a tube running the length of the assembly and drives a piston along a gear rack engaged with both gyroscopes at once. Two pipes feed it, one at either end, and whichever of them opens decides the direction, the whole loop, at quarter speed. Lean, precess, rod valve, air, rack, and the wheels are driven far harder than they would ever turn alone. 6 steps, small valve, large piston, times 367, tip, sense, amplify. Correct. Level. November 1909. The press came down to Gillingham to watch a full-size car stand upright entirely by itself, with nothing whatever to lean against. The year after that, White City in London. 50 people standing on an open deck, no rail beneath them but the single one, and no outriggers anywhere on the vehicle. Every passenger crowds to one side at once, and the floor beneath them does not move. Winston Churchill rode it here, then took the controls and drove a lap himself. Cut the engine, and the sealed rotors held the whole car upright for half an hour. The money never came, not because the machine had failed in any way, and not because anybody who saw it ever doubted that it worked. Every carriage needs its own pair. 10 carriages means 20 gyroscopes, and 10 engines running just to keep them turning, moving, or standing still. And Britain already had its railway network, dense, complete, and paid for decades earlier. Nothing left to build. One of the 2 cars was broken up for scrap. The other ended as a shelter in a Rochester park, sat in out of the rain until 1930. What is left is one of the cleanest ideas in all of engineering. A machine that sensed its own failure, amplified that signal, and turned it into the very force which saved it. In 1909, with no electronics of any kind, Brennan did not lose to better physics or a better machine. He lost to a railway that was already there.